Why are there no meteorites in impact craters? Were they taken by aliens? Actually, the empty craters aren't because the meteorites escaped, but due to the violent impact itself. When asteroids enter the atmosphere, they typically travel at 10-70 kilometers per second, dozens of times faster than bullets. This means when they hit the ground, it's like a nuclear explosion. Take the Barringer crater in the US for example. 50,000 years ago, a 50-meter iron meteorite struck, creating a crater 1.2 kilometers wide and 170 meters deep. But nothing remains in the crater because the impact energy was so enormous. Kinetic energy increases with the square of velocity. The 50-meter meteorite weighed about 300,000 tons, traveling at 20 kilometers per second, equal to 2.4 million tons of TNT. An iron meteorite would instantly be compressed and melted, or even vaporized. Nothing of the original body remains. Meteorites are essentially space rocks, just with higher metal content, in temperatures of thousands, or even tens of thousands of degrees Celsius. Meteorites dozens of meters across often vaporize, leaving only debris. Even 65 million years ago, the 10-kilometer dinosaur-killing asteroid mostly evaporated. The remnants spread globally through the explosion and atmospheric circulation, forming an iridium-rich layer known as the KPG boundary. For medium-sized meteorites hundreds of meters across, they might partially vaporize, partially melt into liquid, mixing with surface rocks. The iron meteorite from Barringer crater mentioned earlier had about 70% melted into tiny droplets, scattered several kilometers outside the crater. But the original meteorite was gone. The melted meteorite was like spilled water, becoming one with Earth itself. If the meteorite is even larger, it might create a meteorite shower. First, it breaks apart during atmospheric entry, like the 1947 Sikhote-Alin event in Siberia. Thousands of fragments scattered over tens of kilometers, leaving only minimal remains in the crater, later buried by geological activity. Compared to the Moon and Mars, Earth's meteorites, including impact craters, rarely persist long-term. First, meteorites encounter atmospheric friction. Small ones burn to ash, disappearing as meteors. Larger ones lose significant mass. For instance, 100 tons of micrometeorites reach Earth daily, but can't survive atmospheric entry. When they occasionally form impact craters, thousands of years of weathering fill and smooth them. The visible craters today, like Barringer crater, survive only due to desert conditions. 65 million years ago, the dinosaur-killing asteroid's impact crater now lies buried under the Gulf of Mexico. The best place for long-term meteorite preservation is the Moon, 380,000 kilometers away. Its countless impact craters are direct evidence. Without an atmosphere, meteorite fragments below escape velocity, ultimately land near lunar crater sites, remaining exposed for millions of years. Today, Earth's best meteorite hunting grounds are remote deserts and Antarctica. Scientists have even found Martian meteorites in Antarctica, likely from asteroid impacts on Mars, creating debris that, through gravity, traveled millions of kilometers to Earth, landing in Antarctica.